Hi, let's solve the second question from today's weekly contest, that is number of subarrays that match a pattern. In this question, we are given a zero indexed integer array, nums of size n, and another integer array, that is pattern of size m. And pattern only consists of integers minus 1, 0, 1. Now, a subarray nums ij of size m plus 1, right? So it is of fixed size. That is, pattern size is m. So subarray that you have to consider is of size m plus 1. And it is said to match the pattern if the following condition hold for each pattern of k. So let's say pattern of k stores minus 1. So what happens is you have to check if nums of I plus k plus 1 is less than nums of I plus k. Correct. And if nums of if pattern is 0, right, pattern of k is 0, then nums of I plus k plus 1 should be equal to nums of I plus k. And if pattern is 1, right, then you have to check for this condition, right? So what that basically means is, let us try it out here. What the question says, you are given this nums array and you are given this pattern. So 1 means that, let's say, a is the first element and b is the second element, right? So 1 means that b should be greater than a. Similarly, if minus 1 is there, right, this is for 1. If minus 1 is there, that means b should be less than a. And if 0 is there, then a should be equal to b. So this is the meaning of 1, minus 1 and 0 in pattern of these integers. Okay, and now what we have to do is, its size you can see is 2. I have to consider all the subarrays of size 3 inside of nums array and check if this pattern holds true, right? This whole patterns array holds true inside of nums. How many subarrays are there, right, of size 3? All right, so here pattern 1 comma 1, it means that, let's say I consider, because I have to take 3 elements, let's say I have x, y, z as my elements. So for that subarray to be a part of answer, what should be true? It should be something like this, that is, x should be less than y should be less than z. Okay, so now let us check. So now we have these first 3 elements, we will check for them. So we have 1, 2, 3. Does this hold true? That is, this is x, y, z. Yes, it holds true. 1 is less than 2, 2 is less than 3. All right, now we will consider the subarray from that starts with 2. So we'll come here and we will consider 2, 3, 4. For it also it holds true. So until now I have got 2 subarrays for which it holds true. Then we will come to 3. So 3, 4, 5. Again it holds true. So 3 subarrays in total. Then we will come at 4, 5, 6. So now the answer becomes 4. And obviously now we cannot consider any more subarrays of size 3. Right? So answer in this case would be 4. Now let us go and check for the second input. So in the second input, the pattern given to us is this. So 1, 0, minus 1. So the what should be the subarray size? The subarray size should be m plus 1. And m is 3. So subarray's size is 4. So we have to consider all the subarrays of size 4 from nums. Now what is the pattern? Let me consider. So I'll take 4 elements as v, x, y, z. Now let's insert these symbols here, right? The operators that we have to check for, less than, equal to, or greater than. So 1 means less than, we should be less than x. 0 means x should be equal to y. And minus 1 means z should be less than y. So this is the pattern that we have to follow. Okay, and we have to count how many subarrays satisfy this pattern, right? So let's see in nums. So the very first subarray is this 1, 4, 4, 1. So for this, does this hold true? So this is v, x, y, z. So I can see that v is less than x, definitely. These two are equal, definitely. And this is greater than 1, definitely. So there is one subarray that I have gotten up till this point, which follows this pattern. Let's move to the second one. Second one is this 4, 4, 1, 3. Now if I check v less than x, no, right? Because these are equal. V is not less than X. So immediately I'll say this is not an answer. So I'll move to the next subarray. If I'll move to the next subarray, I come to 4, 1, 3, 5. Now let's check here. Again, 4 is less than 1. No. Immediately cross this subarray and move to the next one. So the next subarray starts with 1. So 1, 3, 5, 5. Is 1 less than 3? Yes. Check for the second condition. Is 3 equal to 5? No. So again, this is not an answer. So we'll consider the next subarray. So the next subarray starts with 3. So this is the last subarray. So here I can see that v is less than x, yes. And x is equal to y, definitely. And y is less than, and this 3 is less than, z is less than y, correct? So that means this is also an answer because it follows this pattern. So I'll include it in my answer. So the final answer I get is 2. So out of all the subarrays of size 4 in nums, there are only 2 subarrays that follow the pattern. So I hope the question is now pretty clear. Now let's discuss how we are going to solve it. So you can already see here that it is fixed size sliding window problem, right? Because all you are trying to do is you are just sliding the window by 1, and it is fixed size because you have to only consider subarrays of size m plus 1, correct? So that is all you have to do. And while going inside of this particular window, you have to check for this pattern. So to check for the pattern, I will write a check function in which I will send the value of the pattern, and I will send these characters, right? So already in the question it's mentioned this is what you have to check, and only in this way only I will send it, right? So that is all that you have to do. Let's quickly go to the code. There's not much of the logic. That is all. Whatever we are doing is that has been implemented here as well. Okay, so as I said, I have written the spool check function. Inside of it I am passing what is the current pattern value. So if it is 1, then we have to return a is less than b. If it is 0, we have to return a equal b. And if it is -1, then we have to return a greater than b, correct? Now then what we will do, we'll take the sizes and an answer, right, to consider the number of subarrays that follow the pattern. And then we are simply iterating. We are iterating in the nums array up to n minus m minus 1 index, okay? And then we are taking this bool okay is equal to true. Why? Because as you saw in this case, when we were considering the second subarray, right, so there was a point where this became false. So here only it became false. So instead of going and checking everything, I'll say this is not a subarray, and I will set okay to false here. If this subarray is not going to satisfy the pattern, then I'll set okay to false, and if okay is false, then I will not consider it an answer. I will only consider a particular subarray as an answer if this okay remains true. All right. Okay, so here it's okay, and now I am iterating in the subarray. So the subarray size is m plus 1 obviously, but we have to iterate in the pattern, and using I plus j and I plus 1 index, we are checking whether or not the pattern is being followed, right? So here in A we are sending the nums of I and nums of I plus 1, right, in B, and then we are simply comparing if the pattern, whatever value is inside of the pattern, it can only be 1 0 minus 1, correct? So we are simply checking these three conditions, and we are simply returning if a is less than b. So it will, if this is true, it will return true. If it is false, it will return false. So if at any point, let's say this condition is not satisfied, I'll set okay to false. That means this is not a subarray that I want to consider. It is not following the pattern, and I will also break from here, because what is the use of checking for rest of the array when it is not, it is already not satisfying the conditions, right? And as I said, if we do not set okay to false, then that particular subarray is following the pattern. And if okay is there, that is, if okay is still true, that means I have to include it inside of my answer. So that is it. After iterating here, I can simply return the answer. Now, talking about the time complexity and the space complexity for this, you can already see that we are only iterating in the nums array whose size is n, right? And we are iterating until n minus m minus 1. So we can say that we are iterating only n minus m number of times inside of this nums array. And after that, because of this loop, so see, the only catch here to calculate the time complexity is that even though it seems it is fixed size sliding window, but that fixed size is dependent on this variable, that is the size of the pattern array, right? So because of that, because it's variable, right, although the for a particular test case the window size will be fixed and that will be equal to the pattern size, but still while calculating the time complexity we have to consider its size because it's going to be variable, it's not going to be only 3 or 2. So that's why the whole time complexity in the worst case would be big O of m into n only, right? And for space complexity, as we can see, we are not using any extra space, so it will be big O of 1 only, so constant space, and time complexity is big O of n into m.